Okay. Good evening, everybody, and welcome to the public informational meeting for state project number 7-266, replacement of bridge number 06955 on Glen Street in Berlin. This is a live event that is also able to view on YouTube and is also being recorded. Next slide, please. Just a quick overview on how to view captions and subtitles in Zoom. You can click below at Show Captions, select the speaking language, and then choose from the language you would like to see, from the list shown. Closed captioning is also available on the YouTube after the event. My name is Mark Burns, and I'm the project manager for the local bridge program for the Department of Transportation. And here's my contact information. This is a slide on Title VI Civil Rights. No person shall, on the basis of race, color, or national origin, be excluded from participation or subject to discrimination in the development of this project. We highly encourage you to fill out a voluntary post-meeting survey located at the QR code right there and at the link. There's also a slide from the Department's Office of Equity regarding Title VI and civil rights. As stated previously, a recording of this presentation will be posted to YouTube after the event. This is another slide regarding Title VI and notice to the public. Also available in Spanish. The goals for tonight's meeting will be to interact with the project team, explain the federal local bridge program's design managed by state or DMS program. We'll have welcoming remarks by the town engineer. We'll also have introductions of the project team, followed by a formal presentation of design progress, which will explain the condition of the existing bridge and define the purpose and need, and will recommend our viable proposal. Please bear in mind that our design plans are only at 30% complete, and we are still in the process of refining the design. Following the presentation, we'll have an open forum for your questions and for answers. Here's a quick slide on how to use the Zoom Q&A. There's a Q&A button below on the bar of the Zoom, and it will display a pop-up window where you can type in your question in the text box. You can also call in and ask a question too as an audio participant. Here's ways to reach the project team by email at dot-flbp@ct.gov, by phone, which is a monitored voicemail line at 860-594-2020, and during this Zoom event, you can use the Q&A. We also encourage you to visit the project webpage. The comment period is open until May 1st of 2024, but the Zoom Q&A is only available during our live session. The funding for this project is through the Federal Local Bridge Program and through the Design Managed by State or DMS program. In the past, there was an 80-20 split between federal funds and town funds for design, rights-of-way, and construction. In the DMS program, design, rights-of-way, and construction phases are now funded with a minimum of 80% federal and a maximum of 20% state dollars. All design, right-of-way, and construction costs are at no cost to the town. And even though the department is taking over the design, it is still a full partnership with coordination with the town. The reason for the DMS program was to provide a streamlined approach to design using all our DOT resources, to aid the towns to keep their bridges in a state of good repair, to decrease typical design time from upwards of 5 years to a 3 to 4 year design phase, and to utilize accelerated bridge construction or ABC techniques to shorten construction durations, and to increase the number of municipal projects delivered to construction each year. I'll now turn over to the town engineer, public works director, Mike Ahern from the town of Berlin. Mike.
Thanks, Mark. Again, I'm Mike Ahern, town of Berlin public works director and town engineer. When I first started getting involved in this project, the town actually had a rehab approach to the project. And then during the process with the Army Corps and the state agencies, we got comments and concerns about that approach. Then Tropical Storm Ida hit the bridge, and it rapidly became a a full bridge replacement project over time. And just I'd like everyone to know also that the activity that some of you folks might have seen at the bridge starting in December 2021 and early 2022, that was focused on emergency repairs to stabilize the bridge so we can take this bridge through design, permitting, bidding, and then ultimately into construction. So that activity was really focused on stabilizing the bridge as it is right now. So, and I'd like to, any questions that anyone has, they're welcome, as Mark said, to send them in, to call them in. And then even after this, you can call my office or some of the members of the engineering team to get some answers. So with that, I'll turn it back to the engineering team for so they can get into some of the details. Thank you.
Great, thank you, Mike. I'll now introduce the project team from the department and from CHA, or Clough Harbor and Associates, who is our department's consultant liaison. Our division chief is Bart Sweeney. Our unit's principal engineer is Derek Lassard. As I said previously, I'm Mark Burns, the project manager. Project engineers are Michelle Rain and Jeff Organak. From the department's Office of Rights of Way, Zachary Garino. And from CHA are Anand Sasadri and Stephanie Dubina. Here's a quick slide on some basic structural elements of a bridge. The traditional wearing surface is otherwise known as the deck, which has parapets included to prevent vehicles or pedestrians from going from any hazards. Supporting the deck is the bridge superstructure, which in this picture is steel beams. Supporting the deck and the superstructure are the bridge substructure, otherwise known as the abutments. And in some cases, depending on the span length, or the piers. Wing walls are usually used to retain soil behind the abutments. Our bridge conditions are rated from a scale of 1 to 9, with 9 being excellent and 1 being a state of imminent failure. But before any structure gets to a level 1, the town would be notified, and all bridges are inspected on a regular basis by the department. Here's a quick example of some different types of concrete deterioration. Efflorescence is a situation in which chemicals inside the concrete react, causing that white substance that comes out. Honeycombing is as a result of freeze thaw and water inside the concrete freezing. Scaling is a situation where there's additional wearing over time. Map cracking is another situation of different kinds of cracking based on deterioration. And spalling is a more severe case of honeycombing, where the freeze thawing cycles are much deeper within the concrete. I'll now turn over to Stephanie, who will begin the formal presentation. Steph?
Thank you, Mark. So tonight we'll be specifically talking about state project number 0007-0266. It's the Glen Street Bridge over the Mattabesset River, bridge number 06955. With this aerial view, you will see that bridge number 06955 is located in the center of the page. Glen Street runs north to south through the town of Berlin, and the Mattabesset River flows below the roadway from west to east and flows into Paper Goods Pond, located northeast of the bridge. You'll see here that Robindale Drive and High Street are located north of the bridge. And it's fairly wooded with residential housing around the bridge. This is some existing bridge data for this bridge. The roadway width of Glen Street is 24 feet wide. It has an average daily traffic count of 805 vehicles. The speed limit is 25 miles per hour. That's the design speed, while the 85th percentile speed is 43 miles per hour. Glen Street is classified as an urban local roadway. Some additional bridge data. This bridge was constructed in 1957. It's 67 years old. It has 2 spans. The southerly span is a 12-foot by 5-foot rise by 46-foot long precast concrete box culvert. while the northerly span is an 11-foot by 7-inch span with 7-foot 5-inch rise and 52 feet long corrugated steel pipe arch. As Mike mentioned earlier in the presentation, there were some emergency temporary repairs that were conducted by the town in 2022. Those were primarily for the corrugated steel pipe arch, and they included 5-inch concrete invert liner, steel sheeting that act as cutoff walls at both the inlet and outlet, and riprap along the stream bed at the inlet and outlet. So looking at hydraulics, this bridge is considered to be hydraulically inadequate based on the 100-year storm. Hydraulic adequacy can be measured in several ways. Horizontally speaking, the clear span of a bridge is measured from one end of the culvert to another. In this case, the clear span of this bridge is 23 feet 7 inches, which is much less than the 1.2 times bank full width of 27 feet. In this photo, you'll see that the blue line represents the 100-year storm. Note that it's over the roadway. Freeboard is the distance between the 100-year storm and the low point of the roadway. And as you can see here, this bridge does not provide freeboard. Likewise, underclearance is measured from the 100-year storm to the low chord elevation of the bridge. And again, there is no underclearance provided at this bridge. This is a table on the right here showing the latest bridge inspection report readings from March of 2023. As Mark explained earlier, the conditional ratings of a bridge are rated from 1 to 9. The higher the number, the better the bridge element, the better condition of the bridge element. You'll see here that the culvert rating is in good condition, rated at a 7. This is because of those emergency repairs that were performed by the town in 2022. In 2019, the bridge was rated in critical condition, and that's why those repairs were made. And like Mike said, those are only temporary in nature, so that is why we're here today. Another issue with this bridge is that the load rating is substandard. There's a 7-ton weight restriction on the bridge. I'm going to move on to some site photos of the bridge itself. So the top left photo is the eastern outlet elevation of the bridge. You can see this has a 16-inch sanitary sewer main attached to the bridge fascia. This is a major design element for this site. On the top right photo is the western inlet elevation view of the bridge. This bottom left photo is Glen Street looking north. This arrow here points to where the Robindale Drive intersection is, north of the bridge. And this bottom right photo is Glen Street looking south, and this arrow points to the driveway of 85 Glen Street. Here are some photos of the structure itself. This is an inside view of the concrete box culvert. This top right photo shows misalignment of the roof sections of this culvert. The bottom left photo is an inside view of the corrugated steel pipe arch culvert. And if you look closely, you can see that concrete invert liner that was installed in 2022. And this bottom right photo is the condition of the corrugated steel pipe arch and its bolt connections. This top left photo is the condition of the concrete southeast wing wall. This top right photo is the inlet of the precast concrete box culvert. This bottom left photo is taken from Glen Street on the roadway looking down at that sanitary sewer main attached to the bridge fascia. And this bottom right photo shows some of those emergency repairs from 2022. It shows riprap and scour protection in front of the corrugated steel pipe arch. Finally, looking at some field photos of the channel itself, the top left photo shows the Mattabesset River looking upstream. The top right photo shows the Mattabesset River looking downstream. The bottom left photo is taken from the backyard of house number 207 Robindale Drive. And on the bottom right, this photo shows the same property looking at the Mattabesset River during a flood event in 2010. So based on the existing conditions of the bridge and analysis, we have come up with the project's purpose and needs. So purpose for this project includes eliminating the weight restrictions, increasing the roadway width to provide a dedicated 5-foot minimum bicycle, pedestrian lane, and pedestrian path per the town's request, and to replace the bridge rail system to meet current MASH standards. Needs for this project include maintaining sanitary sewer service during construction, setting the bridge's low chord and proposed sewer main invert to the same elevation of 123.4 to avoid sewer main redesign, to improve the bridge's hydraulic performance overall, and to provide freeboard and eliminate overtopping. Based on the purposes and needs of the project, it was determined that the proposed rehabilitation for this site should be a full bridge replacement with twin box culverts. And I'd just like to note here that despite the deficiencies of this bridge, the bridge is considered to be safe for the traveling public, and it is regularly inspected by the Connecticut Department of Transportation. So here's a list of the proposed improvements for this bridge with the new twin precast box concrete culvert. The bridge will carry AASHTO design, legal and permit vehicles, and will therefore eliminate weight restrictions on the bridge. A 24-foot wide roadway will be provided with a 5-foot minimum bicycle pedestrian lane. The service life of the bridge will be 75 years and it will have minimal maintenance. This type of bridge is generally easier to construct and maintain over time. An open bridge rail system and approach rail system will meet current safety standards. We'll have several hydraulic performance improvements as well. This 40-foot clear span will meet 1.2 times the bank full width. The reduced backwater, it will reduce backwater elevation from 4.6 to 1.2 compared to natural conditions. It will eliminate roadway overtopping, which is the most significant hydraulic improvement at this site. Roadway overtopping during a 100-year storm event. And that will actually provide 1.5 feet of freeboard. Finally, the bridge will have overall improved aesthetics. There will be wing walls with form liner applied to concrete simulating stone, similar to this bottom photo here. And there will be a metallized open bridge rail system of the color of the town's choice, something similar to the top photo. I'm going to now move on to some of the bridge drawings. This is the proposed bridge cross section. This is looking north as if you're looking towards Robindale Drive. So the bridge will carry 2 10-foot travel lanes, 2 2-foot shoulders, And on the western side, have that 5-foot minimum bicycle pedestrian path. There will be an open bridge rail system. The bridge will be supported by the twin box concrete culverts in orange here. The sanitary sewer system will be set at the same low chord elevation as the existing, which is in purple here. And overall, the culverts will protect the sanitary sewer from storm events. This is the proposed bridge elevation. This is an eastern elevation of the bridge. So again, in orange are the two twin box concrete culverts. The northern culvert will be 20 feet wide by 8 feet with an 8-foot rise and 1.6 feet of natural stream bed material. This will act as the main flow channel for the Mattabesset River. While on the southern side, the culvert will be 20 feet wide by 5 feet 6 inches tall and no stream bed material. Again, that sanitary sewer main will be attached to the bridge fascia at the same elevation as the existing. The gray represents the wing walls that will contain the roadway. We have the open bridge rail system above that. And here you see that 1.5 feet of freeboard is provided for the 100-year design storm, which is the main reason why this type of structure was chosen at this site, because it provides the freeboard. This is the proposed bridge plan. So to orient you, the Glen Street runs from north to south. The Mattabesset River flows from west to east. The orange are the two 20-foot wide concrete box culverts. The gray are the wing walls. The purple is the proposed sewer main attached to the bridge fascia. This is the roadway plan. So again, the Glen Street runs from north to south. The Mattabesset River flows from west to east. The project will begin with roadway reconstruction in the yellow after the driveway of 95 Glen Street, and will be reconstructed up almost to the intersection of Robindale Drive. It'll end before the Robindale Drive intersection. There are some drainage improvements along with this project. So on the west side of the roadway, there are 2 catch basins that will be installed that will discharge stormwater into the channel upstream. And on the outlet north of the bridge will be modified to a 24-inch pipe, and riprap will redirect stormwater discharge away from the northwest embankment to the channel upstream through a drainage swale. In addition, I'd just like to note that this northwest embankment will be protected by riprap. This is the proposed roadway profile. It's an exaggerated scale, but we just wanted to pull this up to basically show that the profile of the roadway will not change for this project. So this is our detour routes. The Glen Street Bridge is located here in this circle. The bridge will be closed during construction. There are 2 relatively short detour routes that are available. Ultimately, the town will decide which one is best suited for the needs of the public. So as previously mentioned, there are some utilities on the bridge. That 16-inch gravity sanitary sewer main will be temporarily supported and maintained during construction. There will be a 1 foot westerly shift of the bridge's alignment to avoid any conflict with that sewer main during construction. The proposed sewer main will be supported by the new bridge, and the bridge's low chord elevation will be set to match the existing sewer main invert. This will avoid any major redesign or reconstruction of the sewer main itself. And as previously said, the culverts will protect the sewer main from any storm events in the future. In addition to the sanitary sewer, there is a gas main and a water main below Glen Street. These will be temporarily relocated and maintained during construction. And while there are some utility poles around the bridge, there are none that cross the bridge, and there are no impacts to overhead utilities at this site. And we'd just like to note that the residents' utility services will be maintained during construction. Moving along to environmental and historical impacts, there are no significant environmental impacts proposed with this project, and there are no historical impacts. There are a few anticipated regulated permits. Those include the Town of Berlin Inland Wetlands Permit, the Connecticut Deep Flood Management Certification, and the U.S. Army Corps of Engineers Self-Verification Registration. There are a few rights-of-way impacts with this design. Looking to start to orient you again, Glen Street runs from north to south, and the Mattabesset River flows from west to east. Looking on the western side of the roadway, there are permanent slope easements here in green, and drainage rights-of-way easement highlighted in green here and here, and a temporary construction easement in purple. Moving on to the eastern side of the roadway and bridge, there is one temporary construction easement proposed northeast of the bridge on this first property on Robindale Drive. And with that, I'm going to pass it along to Zach from the department's right-of-way unit to discuss the rights-of-way process.
Thank you, Stephanie. My name is Zachary Garino, and I'm a project coordinator with the department's Division of Rights-of-Way. Our office is responsible for acquiring property rights that are needed for transportation projects. As mentioned in the presentation, this project will require the acquisition of property rights, so I'd like to give a brief overview of our acquisition process. Before I begin, I'd like to mention that the specific impacts are still being finalized, and they may change as the design progresses, and that any required property rights will be acquired in accordance with Connecticut General Statutes, sections 13A 73 and 13A 98E, as well as the Uniform Act. You go ahead and change the slide. So the right-of-way acquisition process begins once a design has progressed to a development milestone and all the impacts have been determined. At this point, each affected property owner will receive a formal letter of intent to acquire from our office, along with a property map, which will depict the exact property rights to be acquired. And on the screen here is an example of a property map that an owner might receive, showing the proposed impacts to their property. Next, our office will determine the fair market value of those property rights which were depicted on the property map, which will be used to establish an offer of just compensation. That offer will be sent out to the property owner in writing, and a right-of-way agent will be available to meet with the property owner and explain the project, go over the specific impacts to their property, and explain how the state arrived at its offer. The property owner will be given a reasonable amount of time, typically 30 days, to consider the state's offer and enter into negotiations. When an agreement is reached, the department will prepare all the necessary paperwork to record the deed and property map on the town land records. However, if an agreement cannot be reached, in order to keep on schedule, the department may acquire the necessary property rights through its power of eminent domain. In that event, the state files a notice of condemnation in the Superior Court along with a monetary deposit and the amount of the state's offer. The owner would have 6 months from that date to file an appeal if they felt that the state's offer was inadequate. Whether or not the owner chooses to appeal, the money deposited in the court is available to be withdrawn by the owner. It's important to note that the state only acquires property rights that are needed for the project. If there are any questions regarding the right-of-way acquisition process, I can answer them after the presentation. And with that, I'll hand it back over to Stephanie. Thank you.
Thank you, Zach. Looking at the project schedule and cost, the schedule construction is set to begin in the spring of 2026. This is subject to the regulatory permit approvals. We anticipate a 1-season construction duration, which is approximately 8 months. The construction cost is $3,510,000. And as Mark mentioned beginning of the presentation, that's with 80% federal funds and 20% minimum state funds at no cost to the town. And we'd just like to note that the cost and the schedule are preliminary, so they may be subject to change. And with that, I'll now pass it along to Michelle from the Connecticut DOT to moderate the question and answer session.
Hi, everyone. It's now time for our live question and answer part of our presentation. You can send us questions by email at dot-flbp@ct.gov or by phone at 860-594-2020 and leave a voicemail, or by chat, our live chat, which is down at the bottom of the screen. You can post a question and we'll answer it live here. That's only available during our live question and answer section right now. Or you can access the project web page, which is a link. I just posted it in the chat for everyone to see. You can click that link and you can access that as well. I just want to mention that the comment period is only open till Wednesday, May 1st. And so, yeah, we'll keep this open for a few minutes. As of right now, I don't have any questions, but we'll keep this open for anybody that has questions. We'll give everyone here 2 to 3 minutes. If you have any questions that you think of, go ahead and pop them in the chat. Everybody's going to stick around for a few more minutes in case you think of anything. But if you can't think of anything and you think of something later on and you go home, feel free to send us an email, use the phone number, visit the webpage like we mentioned. Like I said, the comment period is open till May 1st. And so even if you can't think of something tonight, you can access questions and comments until that period is over. Okay, guys, I think I'm not seeing any questions here. I'm gonna wrap this up. Thanks for all of your time. Like I said again, oh, wait, we got a question. Judith asked, what is the volume of water that will flow through the bridge now versus later? Will somebody at CHA take this question for us?
Good evening, Tom Bulzak. I've been acting as a hydraulic engineer for this project, and although it is quite difficult to estimate the volume, but I think the person who's asking the question is asking about the amount of flow. And that amount of flow is not related to the bridge itself. It's going to be the same as in case of the existing crossing, because the amount of flow, or so-called volume, it really depends on how the watershed, the entire area which drains through this bridge, responds to the rainfall event. So in terms of a comparison now and in the future, that's going to be the same unless there are some significant changes within the watershed, significant development. However, I need to point out that this watershed in large part is undeveloped, and it will remain undeveloped because it serves as a watershed for potable water, drinking water reservoirs for 3 municipalities in the area. So our expectation, the team's expectations are that there isn't going to be any change in the water amount of water draining through this from this watershed through this bridge in the foreseeable future. Thank you.
Thanks, Tom. I have another question here. What vegetation will be impacted? Will trees be replaced?
Hi, this is Anand from CHA. Yes, actually, there are some trees which is part of the fill slope limits of this project, and those that are part of those grading areas are likely to be impacted. Again, our aim will always be to minimize the removal of minimize the number of trees that are being removed, but whatever are there in the slope limits may get impacted and may need to be removed. These will be identified as the design progresses and will be called for in the plans.
Just to add on to that answer, if there is vegetation that's being impacted on your property, that's something that will be handled through the acquisition process and will be compensated for those items. We don't propose any plantings typically in these scenarios. We're just paying you the contributory value that the vegetation or trees add to the property value. So there'll be some element of compensation for anything lost.
Thank you, gentlemen. Again, we have another question. If Paper Goods Pond is not allowing water to flow properly, how will that be corrected? If the water flow to Paper Goods is slowed down, it will overflow in the backyards on Robindale Drive.
Yeah, I think we are referring to the watershed, the pond, which is significant distance downstream from Glen Street. Stephanie, perhaps you can find a image which will, well, actually this image is good enough. There is a pond just upstream of Route 71, which is controlled by a dam, and that dam creates the backwater that propagates all the way up to the bridge, as a matter of fact. Now, as far as this project is concerned, there is no attempt to correct any of the flooding resulting from the dam. Dam is a historic feature. Perhaps it lost its value in terms of providing hydroelectric energy to paper goods manufacturing, or whatever the reason that pond was created for, or the dam was installed. However, there is a tendency in in the environmental world to remove some of the dams to allow for fish passage and to restore the natural habitat and natural function of watercourses. This project will not address in any way the Paper Goods Dam, and slowing down of the flow beyond or further east beyond the Paper Goods Dam is not being considered or addressed in any way. This is simply a bridge replacement project. And we are faced with the situation, which is a status quo and will remain as such. I don't know if I'm addressing the question. I suspect this is related to the flooding of a particular property on Robindale Drive. Those are the pictures that we included in the presentation. And the picture on the lower right corner right now, that's the result in our judgment, in our evaluations, that's the result of the backwater created by the Paper Goods Dam downstream. If the water flow to Paper Goods Dam is slowed down, I don't think there is going to be any slowing down of the water. The amount of water that is coming to the bridge, leaving the bridge, and continues towards the Paper Goods Dam is going to be the same. As I stated previously, the amount of water is a function of response of the watershed to the rain event. There is no significant change how that water is moving through the crossing under Glen Street Bridge. Thank you.
Tom. I'll leave it open for any more questions for a couple more minutes. Please remember, if you have any follow-up questions, you can email them to the DOT-FLBP mailbox at ct.gov, or call them in by phone 860-594-2020 and leave a voicemail. You can also look at the project webpage, which I have left in a link in the chat box, the webinar chat box. I'm also going to put a link in the chat box to complete a volunteer survey after this presentation. We would greatly appreciate you filling that out. Okay, that is the end of our live question and answer session. Thank you all for joining us. We hope you have a fabulous day. Thank you and take care.
Thank you.
Good night, everybody.